All right, thank you everyone for joining us. Welcome to the January 29th General Meeting of the Central Florida Astronomical Society. I am your president, Frank Kane, and tonight we've got a pretty good ride for you lined up here. It's going to be a fun night, but if you're watching this and you're not a member of CFAS yet, you should fix that. There are many reasons to join. Let me enumerate them for you. One reason for joining is access to our private events and dark sky viewing locations out in Geneva, Florida. So we have some observing get-togethers that we'll talk about more after our main speaker. We also have a vibrant lunar telescope program, thanks to Christopher Hunt, where you can borrow and check out a telescope and some gear and even some new sea stars now. We'll talk about that soon as well. We also have our own private online community on groups.io that you can participate in and trade notes with your fellow amateur astronomers, and quarterly meetings at the Seminole State Planetarium, which is the coolest place to have an astronomy meeting by far. Your membership also includes Astronomical League membership, which includes the quarterly Reflector magazine and their observing programs. And we are a nonprofit 501c3 organization, 100% volunteer powered, so you can be sure that every penny of your membership dues is going toward our mission and not to somebody's pockets. If you're interested in joining, head over to cfas.org for more information. Tonight's agenda, going to kick things off with our main speaker, Bryony Richards of the Energy and Geoscience Institute, with a very fun talk about space mining. We're going to imagine what if Mark Watney actually did something besides growing poo potatoes and did something more interesting like looking for valuable minerals. After that, we'll have our brief club news from me. And we also have another guest, Bill Castro from our own club, on some reference material for lunar observing, which is always a good use of a night. And we'll close things off, as always, with our Astrophotography Showcase. We got some really good stuff to show off this month, so that's coming up soon. And with that, let me hand it over to our main guest, Bryony Richards. Thanks so much for joining us.
Thank you. Apologies in advance if you hear my two dogs in the background. I decided to spend the day at home because we're about to publish a paper, and so I was desperately trying to get away from my PhD students. So I'm going to be talking. Let me see if I can share my screen. Hopefully I can.
Yep. While you're doing that, let me just remind people, if you have questions, go ahead and queue them up in the chat. A little bit of housekeeping there. And do keep your microphone muted, if you would, during the presentation.
Okay, I am going to really hope that you guys see as the presentation version.
Yes.
Okay, great. I just need to find my stuff. Excuse me while I minimize my 10,000 windows on my computer. Okay. Frank, do you know if there's a way where I can see? Oh, it automatically turns off people's videos. I got it. Okay.
Yeah, Zoom works in mysterious ways.
I know it's strange not being able to see anybody. So let's see how I do. Okay, we're going to be talking about beyond the
Uh-oh.
visible. Oh,
Sorry, I think we have the wrong window here. We have a giant slideshow resume slideshow window.
oh, oh, that's not right. You should be seeing. It says your screen sharing. Let me try again. Okay, you should be seeing the presentation screen only.
Yes, we're good.
Good, excellent. Okay, we're going to be talking about mining the cosmos for critical minerals. I'm sure a lot of you have heard a lot about critical minerals lately, especially with our administration change. We are really, really desperate for them. Are we desperate enough to go to the moon or Mars? We will see. See if it'll let me change it. Okay, so I wanted to, first of all, explain where I live. So as an astrophotographer, I am extremely lucky to live in Utah. We have beautiful dark skies, especially even just outside the city where I live. And so this is actually a photo of the aurora this past April, taken from my front porch, which was really, really nice. So we are very lucky to be able to have an observatory in the mountains. This is our little observatory last year. We have a few scopes up there, including the TS optic that I tend to use. My husband, Eric Benedetti, is also an astronomer, astrophotographer. And so you can see his Newtonian on that photo as well on the left, the black scope. We also have a few other cameras, an all-sky camera and a weather station up there. We're lucky in some ways that the mountain behind that you can't see because I'm on it actually blocks a lot of the light pollution. So we're quite lucky to not get light pollution from some of the other cities around Salt Lake. Everybody also always asks about what the setup is. So I said I use a TS optic, so 130mm scope. It's got a guide scope on it and then a remote setup using an ASI Air. I cannot claim to have set any of this up. My husband actually set it up, which was very kind of him. And yeah, so I guess to prove I'm legit, before I go into my geology or astrogeology presentation, I wanted to show a few photos that I've taken. And at my observatory, or my husband's and I's observatory here in Salt Lake City. So on the left here, you're seeing the Christmas Tree Nebula. And on the right, you're seeing the Cone Nebula. I'm going to get out my little laser pointer here. So this beautiful, tiny little nebula is right here. Whenever I see the Christmas Tree Nebula, I was absolutely fascinated by this little blob. And it took a long time to resolve. And it's interesting. It's got this sort of like wave of just beautiful gases behind it. Just gorgeous. So it kind of looks almost like a shark swimming along. Couple of other photos. The one on the left is the Whirlpool Galaxy. I'm obsessed with taking photos of the Whirlpool Galaxy. It's just absolutely gorgeous. I just think the merging of galaxies, this kind of non-turbulent mingling of galaxies, is so far away from what most people think of galaxy collision. And so I find this absolutely fascinating that it's just kind of mingling and kind of joining together. So anyway, for those of you who are interested, obviously the red is the H alpha. So this is HLRGB. Yeah, HLRGB. That's right. On the right here, we have the Elephant Trunk Nebula. This was one of the first complex photos I guess I took and used PixInsight for the first time, I think, to process it. Here you see the Garnet Star up on the right-hand side, which is just one of my favorite things to see in the sky. And of course, here is the Elephant Trunk, for those of you who haven't quite spotted it. However, my favorite nebula, I think, that I've taken from our little observatory is the Bubble Nebula. I find it just absolutely incredible that this tiny Wolf-Rayet star here at the center, I say tiny, a large star at the center, has just produced this enormous shockwave of gas that forms this beautiful bubble, quite similar in this orientation to the Dolphin Nebula, for those of you who know that. I also just think it's fabulous. It also just kind of looks like the light is dripping onto this H alpha portion below. Anyway, I will stop talking super astronomy and go on to spectral astronomy and sort of spectral sciences. As Frank mentioned, I work as a senior research scientist at the University of Utah. And there I am an advanced imaging expert. So I specialize in spectral and satellite geology in remote and hostile terrains, with a focus on scales ranging from astronomical, what you've just seen, to the atomic. So I do everything from sort of the satellite imaging all the way down to the drilling, the SEM, the XRD, the TEM, and all the other acronyms. So as you can see here, spectral and hyperspectral are words we're going to be using a lot in this presentation. It literally just means collecting very high resolution data across continuous or near continuous wavelength bands. And that means that using those wavelengths, which equate to reflectance, allows you to kind of precisely identify material, obviously by detecting their distinct spectral signatures. They're not just points, they're actual sort of signatures for each one of these minerals. And it doesn't really matter whether that's a mineral, a human, a cow, they're all going to have a spectral signature. We're just looking for the mineralogical ones, which tend to be the most powerful anyway. People often ask me what the remote means in my kind of job title or description. And that means wilderness areas, triple SIs, as we say in Europe, sites of special scientific interest, extraterrestrial bodies, and planets in our solar system that we've been able to get to properly. Sadly, the hostile terrains is the bit that includes disasters, bad weather, and war. Obviously, we want to know what other nations have, and satellite technology, especially spectral, can let us estimate their resources. So it's another use for spectral. I do not work in the defense sector. I work in the research sector. So this talk is kind of on spectral imaging in space in a way, but also about mining. So, oops. We'll take a quick look at exactly what spectral imaging is. I've told you kind of what it is, but really what you have is a satellite in space, or if you're really lucky, a plane. And what you do is you push broom photograph, just like anything moving along like a LiDAR or a regular satellite, just as if you push a broom. Each tiny pixel that it photographs, it actually can photograph up to about 400 bands of different wavelengths that we can then look at as a reflectance spectra, and with a few magic tricks, turn it into a beautiful map and then analyze the spatial properties of that map. This then allows us to obviously go after economic interests or things like slope stability in mines, like the big Kennecott mine. We're doing a project there for the CDC. These things can do, spectral science is just absolutely incredible. So we have RGB. You guys all know that because you're combining your monochrome images to make these gorgeous astronomy photos. So those are 3 discontinuous bands. Multispectral is less than 37 bands. You still get a lot of information, but they're discontinuous. And then we get hyperspectral. That's more than 37 continuous bands. There's talk about a superspectral class being added, but who knows if that'll happen. I always like to put an eyeball on here because I like to remind people that the RGB is the visible light. We cannot see the rest. And my grad student, my PhD student would be incredibly angry if I didn't tell you that there is never a continuous spectrum of light photographed. It is always wavelengths. It really bugs him when I say continuous bands. So, okay, so visible light. We've talked about spectral. Where does it fit within our profile of light? So you obviously have your visible light spectrum, and that is this teeny, teeny, tiny part here. You also have your very near infrared, your shortwave infrared, medium wave infrared, and long wave infrared, all within this really small area. We sometimes obviously look at gamma rays. I used to do research for DITRA, and gamma rays were a big part of what we did. X-rays, obviously, I use almost every day to analyze minerals. UV is kind of useful. We actually use it to identify a lot of minerals. Things like diamonds will actually glow in UV light. It's kind of cool. And then, of course, we have all our different filters that we use for things like near-infrared galaxies and dust and stars and everything else. So with that little background about spectral imaging, welcome to the future of space mining. according to ChatGPT, which is unfortunate. ChatGPT, I use it a lot in presentations as a joke. So when the robots come for us, I'm first. With all that said, and with all the awful scientific inaccuracies in this photo, including seeing a Milky Way and a giant moon, it kind of proves the point of how are we going to mine? How are we going to find these deposits, first of all? And then how are we going to process them? Are we going to process them on site, like this shows? I think that's most likely. Or are we trying to get them back to Earth, which would be insane? But anyway, this kind of is a great reflection of ChatGPT. We, however, are going to look at Mars. And Mars has been lucky enough to have an incredible satellite called CRISM. It's part of the Mars Reconnaissance Orbiter, and you may have remembered that being launched, I think, almost 20 years ago now. It's a long time ago. CRISM is incredible because it allows us to identify a really wide range of minerals, including clays, and sulfates and carbonates, carbonates being calcite and all those kind of things. The images on the right are hyperspectral images that are overlain onto what I guess would be a DEM, so a digital elevation model. Unfortunately, whoever did these didn't actually tell you how they did them. But what is really nice to see is that even sort of an orbiter like CRISM is able to pick up this on the surface. It's fairly consistent with our satellites on Earth. And you wouldn't actually have to put so much of an atmospheric correction on it. So that would be kind of cool. Anyway, it provides a lot of insights into aqueous history, different wavelengths, allowing identification of surface minerals, etc. The Mars Express was another instrument that was sent up there for mineralogical mapping using a spectrometer. And that obviously gave us more hyperspectral data, and we've continued to kind of understand the planet's surface. So as you can see, the graphs that we get are actually really quite complex. You're looking here at spectral reflectance, so single scattering albedo effects. And you can see how really every mineral has a signature. It really does. It's complex, but it's there. And it really doesn't deviate. So something like olivine has a fairly simple crystalline structure. It is a magnesium iron silicate. However, this is still complex because we have a ton of noise in there. You know, it's hitting large pixels. And one of the problems with hyperspectral imaging is that getting down below 10 meters is difficult. That means that each pixel in your image is going to be 100 feet squared. 100 meters squared. Anyway, if you are interested in looking at some of this hyperspectral imaging, it's accessible to the public. Almost all of this stuff is accessible to the public in some form because it was paid for taxpayers' money. The actual little unit itself, because we all love to look at cameras and telescopes, is this little thing. It was just absolutely revolutionary at the time. Everything from the sort of data processing unit and the gimbal to sort of the anti-sun shield was really incredible on CRISM. And its wavelengths that it can actually analyze, 362 to 3920, is incredibly wide. We rarely see that on Earth from our Earth satellites. So from that, they've been able to make a geological map, which is pretty incredible. So this uses DMs, obviously just people staring at the surface of Mars. One of my students just loves finding dikes. So these red lines are dikes, igneous intrusions. He spends a lot of time finding those on maps. But it's very useful. We now have a geological map of Mars. What are critical minerals? Unfortunately, my picture's been deleted here, but what's important is this beautiful rock is right here. This actually comes from one of my study areas in the US, the Tintic district in Utah. It's had a continuous mining history from 1968 onwards. So it's very important to us to understand sort of what critical minerals we can extract from the tailings. Anyway, this is kind of what we could possibly find on Mars. This is a mixture of different copper ores. And what's really interesting is these little things down here called blueberries. We've heard about these on Mars. And so I always find it fascinating to see them on a rock that I have. So this rock, in actual fact, is about 5 centimeters big. It's not this big, but anyway, the colors are insane. Critical minerals on Mars exploration. We know of a few areas already that we would particularly go after if we were gonna mine Mars. But as you can see, we don't have an awful lot of information about the surface. It's pretty sparse. And I'm not going to invest right now, put it that way. So, to learn more about whether we should invest in Mars or not, we're going to use something that's really familiar as a case study. We're going to use The Martian. And one of the reasons I love this movie, other than Matt Damon, and I won't go into those reasons, incredible actor, of course, is the fact that it's actually scientifically pretty good. And that's rare. Interstellar is one of the others. And I kind of toyed with doing a presentation on Interstellar as well. But maybe if you have me back, I'll do Interstellar. Anyway, this is Mark Watney. For those of you who haven't seen The Martian, I wanted to give you a quick overview of its plot. So this is Mark. He's a botanist. He loves plants. And he's come to study with his team whether he can grow stuff on Mars. However, there's a really bad storm. And poor Mark, his friends leave him, which obviously really bums him out. He also kind of gets stuck with a big piece of metal, and there's a whole load of drama about that. But anyway, he gets over that, and he decides that the first thing he should do is try and contact NASA. It's pretty smart. So off he goes. He goes to find Pathfinder because he realizes he can back program it. So he finds Pathfinder, brings it back, makes a very, very lovely hex code system to be able to talk to NASA. On the way back, he realizes he's getting a little chilly, so he picks up a nuclear reactor, which is a weird bit of the plot, to be honest, and not very scientifically accurate. But anyway, he gets back home to the hive. I think it's called the hive, and he decides that he's really hungry, so he starts growing potatoes in his own poop. This is also courtesy of ChatGPT, and I'm a big fan of it. They actually managed to spell poop correctly, so we're getting somewhere with artificial intelligence. Anyway, Mark decides that the only way he is going to leave the planet is to spend a long time getting to Schiaparelli crater, where there is a rocket waiting there that was going to eventually take a different team back to Earth. So Mark, on his way, he goes through some beautiful areas. He takes a few naps because all of this is done on solar panels, which is wild. And then he eventually makes it to Schiaparelli crater and goes back to Earth. End of the story, he gets to be a college professor. I'm not sure that's the most romantic job he could have gone back to, given that that's my my lot in life, I guess. So how can we assess the critical mineral potential using advanced imaging of Mark Watney's route from Acidalia Planitia to Schiaparelli crater using hyperspectral planetary geology? So these are the four mats, the four critical mats, because they're looking for critical minerals. So The first mat is going to look at Acidalia Planitia. I'm pretty certain that the critical mineral potential there is lithium, germanium, and strontium because of its lava flows and its sandstones. Second critical mat, the journey to Pathfinder. He goes over some really catastrophic flood deposits, and those probably provide like a lovely transported mix of vanadium, titanium, strontium, yttrium, and all other kinds of rare earth elements. Those are probably transported via erosion down through the streams, water on Mars, from the highlands. Anyone who tells you that there wasn't water on Mars should maybe be sent there. But anyway, midway segment on the journey to Schiaparelli crater, Matt goes through Arabia Terra and Meridiana Plana. It's a rugged landscape and it has cratered highlands and supervolcanoes. So naturally, it has critical minerals. And I'm going to stop listing the elements. Final approach to Schiaparelli crater, relatively smooth terrain, but the crater's interior is probably surrounded by really steep walls of volcanics, which means, again, we have quite a few critical minerals. Let's start with critical mat 1. He's going to move through Acidalia Planitia. So as we said, it's mostly flat. There are a few obstacles like ridges and lava flows, but he gets there fairly easily. It's kind of nice in the movie because I think they got this really, really kind of on point. This is really how it looks. And just to remind you, he's kind of sad because all his buddies have left. So I like to point that out. He looks like he's sad, right? Anyway, scientists are debating right now about these northern plains, whether it was oceans or water bodies or glaciers. There are a lot of possibilities, but there was water. This is kind of my interpretation of what it would have looked like. And you'll probably be like, oh my goodness, that looks like some part of, and say, an earthly destination, because it really does. Mars probably it could have looked very much like Earth for a long time. I wanted to show an earthly analog, so I stole one of my husband's photos that I absolutely adore. This is Checkerboard Mesa in Zion National Park. Here you can see just these beautiful, essentially layers of sandstone. It's called cross-bedding, and this is from a Martian photo. I mean, they are absolutely identical. And the cool thing is that Mars has both the water version of these and the Aeolian giant dunes or dunes, as Americans say, that you see in places like the Grand Canyon. So again, water. For those of you who haven't been to Utah, please come visit. It's gorgeous. You can still buy beer in restaurants. That seems to be most people's put off. But anyway, you can just see these incredible landscapes that, I mean, undoubtedly Mars looked like this because we have photos of it. But this is actually Temple of the Moon and Sun in Canyonlands in Utah. You'll see on the right where I have photos. I like to give a little shout out to my sponsors. They're amazing, and I'm very lucky that I have people who want to sponsor my photography. So thank you to them. I really appreciate what they do. In terms of this photo, what I love is the fact that the Milky Way goes between the two temples. The middle of the photo needs something. Maybe a Martian photoshopped into it, something like that. Maybe I'll do that next time. As I said, Mark eventually wants to go to Pathfinder. So off he goes to find Pathfinder. And he moves through these incredible catastrophic flood events. Floridians, you know about flood events. There's something that you can just see as a scar on the landscape. And what's so incredible about this is that it hasn't been covered by craters which means it's really, really recent, which is mind-blowing. It's just incredible. A nice example of what I think Mars would have looked like is the Dirty Devil River in Utah. I took this with a Nikon Z7. It was about 3 minutes, I think, per shot of the sky. And we see here just incredibly beautiful green air glow moving through the magentas. So air glow from just several levels in the atmosphere. This place is also incredible because it's like a spa. You can just wade through this beautiful silt mud. So we had a few fun days here camping and hanging out. The next place Mark is going to go is Arabia Terra. Ancient volcanoes, possibly super volcanoes, prime for nickel and iron and all kinds of weird stuff like lithium, gallium, rare earths, nickel, cobalt, and PGEs, which is platinum group elements. When I say super volcano, most people, when I'm doing this live, shout at me, Yellowstone. And they're totally right. Oh, he takes a nap as well. And we will get to Yellowstone in a second. However, the hyperspectral imaging shows this just absolutely beautiful photo of what we think is layered sedimentary deposits with these ancient lava flows. And you can see just evidence of several erosionary processes going on. You can see some here up at the top, that beautiful cross bedding we saw in Zion National Park. This is it from bird's eye view. You see volcanoes, you see some craters, but again, not many craters. That means that not only water, but tectonic activity happened not that long ago. Another incredible hyperspectral image, this time sort of looking at portions of the Meridiani, which is another sort of plane with these super volcanoes. This, again, when I ask people, what does this look like? They'll shout, Yellowstone, which is correct. I decided, because I continuously use Yellowstone as an analog for this, I was going to map Yellowstone hyperspectrally on Earth to give me a Martian analog. I really like having analogs. So what I did was, with the spectral data we have on Earth, which is from a satellite called Sentinel-2, what I did was I took the reflectance data, the raw data from the satellite, and then I converted it using a ton of steps into the actual minerals that surround Grand Prismatic, and that's where the two arrows are pointing. So if you've ever been to Yellowstone, Grand Prismatic is our insanely gorgeous, huge pool of hot, steamy water, which is why it's black. I do not map water because it's not a rock. So you can just see an incredible, just these are not all the minerals. These are minerals that are above 1% of this diagram, mostly to get it on this page. So you can see that Mars probably had a very similar mineralogy to the Earth. Oops, let it go. Okay, we're gonna go down a very quick rabbit hole, which is why there's a rabbit in the corner. This is not Mars, this is the moon. But what I wanted to show you is that Earth analogs are not that easy to find for Mars. They're not that easy to find for the moon either, even though the moon is what was part of our primordial Earth. This is why the science that I do is pretty rare. You need a combination of both the knowledge of being a mineralogist and the knowledge of being an astronomer and the knowledge of being a geologist, so, and a spectral scientist. So I'm lucky that I have ADHD and I can read a book really fast. I wanted to show this really beautiful analog that I found up in Montana, the Stillwater Complex, because we're still down the rabbit hole, and I just wanted to show some of the imaging you can get for this. So these are the lunar highlands. The lunar highlands are the white and the red on the two spheres there. This is the still water complex here. I'll show you with my laser pointer. During the daytime, I do a lot of mining geology. And so I am very good at spotting tailings dams. There's one up here too. But this is just littered with just incredibly diverse minerals. But it is one of the only places on Earth that we can find a pure lunar analog. So I asked my computer, I say asked, I spent days mapping this and managed to map the minerals, because what I wanted to find was the same rock exactly that is on the moon. And so this is a huge anorthosite, a type of igneous rock that you find on Earth a lot. However, the high calcium variety of this, which is lunar anorthite, is barely found. There are 2 pixels in this square. That's it. So actually finding mineral analogs on Earth is difficult. And so Yellowstone, it's kind of a playground for us because of that. So I got to show you a few pictures of Yellowstone. As you've probably by now worked out, I'm not American. I have a British South African Kiwi accent. And as a child in England, I would dream of going to Yellowstone. And when I finally did go there as a 26-year-old, it didn't disappoint. So I go there every year, and our little group has grown from myself and my husband to almost half my department, I think. So it's going to be an interesting one this year. One of the things I love to do during that is teach my fellow academics how to take night photos. And also, of course, warn them not to pet the fluffy cows. It's shocking how many people think that they can run faster than a buffalo, but it's kind of funny seeing it sometimes. Anyway, one of the other places I just adore is Morning Glory Geyser. It's just lines up incredibly well with the Milky Way core in late August. Unfortunately, this tree is blocking Ro-Ophiuchi, which is a little irritating. But it's an incredibly active geyser that will actually change color over seasons. So this tells me it has copper in it right away. So we're pretty certain that Mars was littered with geysers like this. This is one of my other favorite geysers. It's called Artemisia geyser. This, I think, is what the surface of a lot of these kind of super hot geysery areas would have looked like. This is a calcium, magnesium, and iron, when you can see the red. It's called travertine. You may have it in your bathroom. And it's probably something that was very prevalent on Mars. The red from Mars is just so pervasive. The rusting, the iron, is that we just don't see these kind of colors very often anymore on Mars. This is the first. I wanted to tell a really brief story about this. So this is one of the first places I ever took an astro photo. And here it is. This was 2015. I went up and decided I wanted to take a photo, and so took a photo, unwittingly kind of addicting myself to this lifelong kind of hobby. This is Blackpool Geyser, and after this, about 3 years after this, I actually had a traumatic brain injury. And one of the things that happened with that traumatic brain injury is that I forgot how to take photos. I forgot how to take night photos. I forgot a lot of things, but that was really important to me. And about 6 months after my traumatic brain injury, I met my husband, and he taught me how to take photos again, which is we met through astrophotography anyway. And so 2015 to 2022. So I don't want to encourage people getting traumatic brain injuries, but it did make my photography better, in my opinion. But um, yeah, it's been quite the journey with astrophotography and deep space. So, and lastly, the final approach to Schiaparelli crater. A lot of critical minerals here. I think all kinds of things like lithium and beryllium. Beryllium's one we really like right now, and germanium as well. So off he goes. And thankfully, he manages to get back to Earth, to his calling of being hopefully a tenured professor at least. I wanted to show you a really beautiful picture that I stole the foreground from and then put my own sky on. So this is if I went to Mars and took a nightscape photo, I think this is what I would have taken, somewhere around here, just about where Curiosity landed in 2012. A couple of other things I wanted to show as sort of Odyssey photos. I just think this is one of the most incredible hyperspectral photos that I've seen taken. You can see the sand dunes. It's just incredible. And not only that, is that the pink is windblown dust, sand dunes just like we have here. And then the purple are volcanic rocks. So if any of you have been to Hawaii and been to the green sand beach, that's what this is. All that purple is olivine. It would have been, well, it is absolutely stunningly beautiful. But the use of a map like this is to see where we have buildups of those things. Obviously, you get the wind-blown dust as you pile onto these volcanic cliffs. If you can imagine these being cliffs, and then you get wind-blown dust within the craters themselves. So we can see where the prevailing wind came from in this area. Just incredible. So my conclusions. I think all the mats would be happy. All 4 critical mats, they get a pretty good go of it. However, if I was gonna bet on somewhere, it would be as north as possible to try and access water. So my last slide, I wanted to kind of explain how I kind of see the future of this. So I asked ChatGPT, like, I want a nexus of computing power and data. And that's our problem right now, is computing power. It's got to the point where I can run a lot of the models, but some of the models I'm stuck without a supercomputer. So we need to get our computer power a little better for us to really explore this data. I work with several big data companies, and fingers crossed we solve it, because I would really like to map more stuff. And with that, I would like to say thank you to my sponsors, Fervent Astronomy. They're a store in Canada. They're incredible. PhotoPro make the best tripods, I think, on Earth. And Fornax mounts are an incredible star tracker. And of course, any questions, and happy Valentine's Day from the spectral world.
Oh my gosh, thank you so much, Bryony. That was fun. I think my wife's wondering what I'm chuckling about in here, but
Oh, good. It's very hard when you don't hear people laughing.
I
I'm like,
know.
ended.
I know. It's yeah, I hear you. Yeah, if anyone has any questions, you can either pop it in the chat or hit the react button on the bottom of the screen and raise your hand if you want to ask live. I have questions though, so I guess I'll indulge myself. So, I mean, first of all, like it was kind of an eye opener to me that there's so much diversity on Mars in terms of minerals. We're kind of taught that it's red because it's made of iron, and we don't really think beyond that usually. But of
Yeah.
course, it has. I mean, it didn't form that differently from Earth, right? Like it's
Oh, no, I mean, we're made of the same stuff.
yeah.
You know, theoretically, it could have been just like Earth. We could have had Venus, Mars, and Earth all having these beautiful, lush green environments. Our ability to actually go there and test stuff. And so I have one of the machines that it's one of its duplicates is on the Mars rover. And it's a machine that I put in some dust and it tells me the chemical composition. It's phenomenal. XRD, X-ray diffraction. You need very small samples. However, it has an error of 10 to 15%. So you can never say how much. You can just say it's there. So
Yeah, cool. So, let's say that 100 people get into a SpaceX Starship, they get plunked on the surface of Mars, and they get kicked out the door and say good luck. Uh, what mineral would they need the most that they would have the hardest time finding?
well, it's not a mineral, but water.
Sure.
Uh, to mine any of this, and I didn't put it in this presentation, but the biggest challenge for mining is water. Always. One of the reasons that Africa has not been more of a world player is the fact that their mining is hindered by not having water. And so I would first go for water, and then I'd probably go for copper for infrastructure reasons. I wouldn't be going for any of my precious crap. I would be finding building materials, and then obviously down the line, mining things that you then use for a spaceport or, rocket fuel or whatever you're going to do.
Mhm. Absolutely. Yeah, and that ties into a question that came in from Bob here, where he does point out the same thing. Massive amounts of water is critical for any successful mining operation. So, yeah, that's step
Uh,
one, right?
and the tricky thing is as well is that you know, one of the sciences is trying to mine with less and less water. And mining always gets a very bad reputation. It's a disgusting, dirty thing that we do. Um, but the critical minerals we mine have a bigger mining footprint than even other minerals. So everybody running out and buying a Tesla, it's so pointless. You're actually doing more damage to the earth buying a Tesla right now when we don't have decent mining strategies. Um, I said that at a conference and someone looked so sad and was like, I took a Tesla to try and save the planet. And I was like, I'm so sorry, but you're not. So
Well, you just gave me another reason to sell mine. So, yeah.
I
Um,
know. Hi, Bob.
yeah. Will and Castro votes for a talk on Interstellar. I second that motion, Bill. That would be awesome. And we got a question from Luke. Uh,
They're chomping at the bit. Whatever conference is next gets Interstellar, but I promise I'll rerun it if you want to.
awesome. Luke says, when taking the hyperspectral images, do you have to take into account the specifics of the solar spectrum illuminating the surface? Hmm.
Yeah. Actually, yes, you do. And that's one of the really tough things that we have to correct for, radiometric correction. So the azimuth of the sun can make a huge difference on reflectance and what is reflected. So before we look at any of these images, the pre-processing steps are just brutal. And they take a lot of time and they're not taught. There's no class on this anywhere. And so most of my students come to me because they really want to learn spectral imaging and mining. And those are both niche areas. So I have a student in Houston who actually her mineralogy classes have been cancelled for 2 years. And the basic things that we need for these future sciences aren't being taught in university, which is baffling. So.
Mhm. Yeah, yeah. The questions keep coming in. Luke has a follow-up. Do you think we are more likely to mine Mars, the moon, or an asteroid first?
Uh, if you're talking to one of my coworkers, it would be an asteroid. But he's a humanities professor, so I don't think we want to believe him. Uh, Personally, it's going to be the moon. It's got to be. There's no other, logical thing to do. We have to use the moon as a jump off. And actually, my other talk was on the moon, so mining the moon. So I have a talk about superheroes mining the moon. So it's got to be the moon first.
Yep, absolutely. A lot easier to get to as well.
Yeah,
Yeah,
no
I mean,
elevator though. That would be a terrible idea. The giant space elevator. Yeah, no.
really? Well, yeah, I guess that would be bad if it broke, which probably would happen. But yeah.
Yeah,
Bob's asks, would the actual mining be done by humans or robots, in your opinion?
robots, AI.
Mhm.
That's one of the main reasons. I'm actually part of an AI research group, and I like to call what we do sensible AI, because it's not what I do for presentations, which is ask it to draw stupid stuff.
Mhm.
We actually have been using AI in a project in Alaska where we can't get there because it's a hostile terrain in terms of, weather, everything. Um, and so, yeah, I mean, with that kind of stuff, it's tricky.
Yeah, people forget there's a lot more to AI than chatbots, so there's actually some use for both of
Yeah,
it.
it's yeah, we've been using it to in Alaska to sort of group the minerals, and then it can predictively analyze then what formations on Earth would contain those minerals. So
Mhm.
it gives us again, everything we do is analog based because before you find something, you have to find the clues. You're a detective, which is I hope why I like murder shows. Um, Apology. So
Oh my. Todd asks, what kind of software is used for the analysis you do? Is it commercial or is it something
so
specialized?
this is the really cool thing. When you piss off scientists, they go rogue. Um, the GIS software pissed off scientists. So they went rogue and they made one called QGIS. It is really good. It's fantastic. You can use QGIS to process hyperspectral images, which you can download from several different places on the internet, very, very easily accessible. And you can experiment from there. They even have plugins and things. I use ArcGIS, but that's because the government pays for it. I wouldn't otherwise because it's like $10,000 a license. It's insane. And then the other piece of software I use is called Envy. It's up there with PixInsight in my opinion for software. So it's yeah, PixInsight and Envy are my two favorite pieces of software, probably because they're both Linux based. But the phenomenal thing about Envy is that it allows you to reconfigure the spectral data. And so recently, what I've been able to do is make a mathematical equation out of the spectral data that I then rearrange to find active hydrogen seeps. So on Earth now, we know where the hydrogen is. And so we'll be publishing that next week, hopefully, in a Nature publication. So fingers crossed.
Very
Um,
cool.
but then we'll be able to also transfer that knowledge to other planets as well. So not just on Earth, where we will hopefully, the algorithm that I made will hopefully allow small villages in Africa to find their seeps and actually use that power in small communities. So that's my dream of that. But anyway, so we do a lot of different things.
Very cool. Bill also votes for the hearing the talk on mining the moon someday, so
Mhm.
got a supporter for that one too. And he also asks, are you doing anything with the LPL at the University of Arizona?
LPL,
I don't know either. Bill, what is
I'm
it?
not sure that large planetary. Is it a telescope or is it a department? I do work with the University of Arizona on several different critical mineral projects. We actually have projects all over the world on critical minerals. We're starting to work in many more countries just because America wants to know what other people have. And it's kind of nice because then we sort of get to go ground truthing. No, I don't work with their lunar and planetary lab. Those guys are pretty unique. They they're not big thinkers. They do microscopic work mostly, but yeah, they're phenomenal. I have a friend that works in that lab.
Awesome. Thank you. And I think we're caught up on questions. If there's any last minute ones, this is your last chance, folks. Going, gone. No. And if not, thank you so much for joining us tonight, Bryony. That was a super fun talk, and I learned a ton about Mars and also what Mark Watney's head looks like. So
Yeah. Awesome.
Thanks so
Thank you
much.
for inviting me. I appreciate it. I will hang around in the background in case anybody, unless I'm not allowed to listen to the
Oh,
membership,
no, you're
um,
absolutely welcome.
background in case anybody wants to ask any questions in the chat. And I'll just listen in, but go silent.
Thanks so much. Thanks for joining us. And yeah, feel free to hang out and geek out with us here. So
Oh, I will.
thanks so much. Cool. All right. And with that, I will share my screen. Hopefully, let's see if I can figure it out. Share. You should be seeing a giant screen that says Club News. Yes, I think it worked. Yay. So, what is going on with CFAS this month? Well, we got another meeting lined up in just 2 weeks, so it's not a heck of a lot to talk about between now and then, but more than you might think. Our observing nights at Geneva are lined up for January 31st, February 1st, and beyond that, the 21st, 22nd, and 28th, weather permitting, of course. You keep an eye on our groups.io communications as to whether or not we're going to be going forward with that the night before. And there are dates for that booked even beyond that. Check the calendar on cfas.groups.io for future dates for observing nights at Geneva. Always a good resource for getting out there in some darker skies and also meeting with fellow members and getting some advice on how to use your telescope and what their telescopes are doing. Also, a reminder, we've got the exhibit at the Orlando Museum of Art coming up on April 17th, where we'll be showcasing members' astronomy-related art and astrophotos and sketches, whatever you got. Go look for Wes Clem's announcement if you missed that, if you want to get your submissions in. We've got a pretty good amount already, but we basically have infinite space there. So if you haven't already submitted your best work, go ahead and submit it to Wes. And we just have to get them by February 28th. So you got a month left to go and polish those up. The deal is there, you will be responsible for printing and, making that something that can be hung on a wall. But at that point, we'll take care of getting it displayed and getting it in front of thousands of people. That's actually coinciding with a free admission night at the Orlando Museum of Art. So we're expecting quite a bit of traffic there. So fun stuff and a good way to spread the word about CFAS. Our next in-person meeting is going to be on March 15th at the planetarium. So mark the calendars for that. Our own Derek Demeter will be giving a planetarium program about women in astronomy. So that'll be fun, followed by our usual breakout sessions and munchies as well. And we have a couple of Zoom meetings lined up as well. In just a couple of weeks, we're welcoming Amy Oliver from the Whipple Observatory. That's the Harvard-Smithsonian Observatory down in southern Arizona, where they're doing some cool stuff. She'll be talking to us about star evolution and how some of the latest research at the Whipple is contributing to our understanding of that. Then on April 9th, we got a special guest, Avi Loeb from Harvard. He's the guy that wrote Extraterrestrial, that book about, is Oumuamua really an alien space probe? And more recently, he's been in the news for digging up interstellar meteorites from the bottom of the ocean and postulating that they might have interstellar technological origins. So, controversial guy for sure. I'm going to talk to him and we'll find out what he really thinks. Is this really just a way of like encouraging people to do more big thinking and pursue research ideas that the academic community doesn't normally go after? So don't miss that one on April 9th. Abbey Loeb, that's going to be a fun one. And our outreach calendar is absolutely packed. I cannot believe how many school groups and everyone else in community groups want telescopes at their events, and we're supporting them as best we can. We do need your help, though, so if you want to share the view through your telescope, please head over to cfas.groups.io/g/outreach to join our outreach group there, or contact Doug Woods, our outreach chair, at outreach.cfas.org to get involved. And for all of you who are participating, thank you so much. And also, our Lonerscope program is expanding. So we have added some C stars. That's the latest hotness, those little compact ZWO smart telescopes, and more telescopes as well. We've got some 8-inch Celestrons in stock, 10 to 12-inch Dobbs, some C11s, some Newtonians, whatever you want to try out. Take advantage of that program to try before you buy, if you will. And thank you so much to Christopher Hunt, our Lonerscope program chair, for managing all that and making it all happen. If you want to learn more about that membership benefit, contact loners at cfas.org. Also, we've had a huge surge in membership this month. So if you're watching this for the first time, welcome. Thank you so much for joining. A lot of people want to look up instead of down lately, it seems. So we're happy to help. If you are a new member, be sure to read the Welcome to Central Florida Astronomical Society letter that you got automatically when you signed up. That explains how to access that community on groups.io I've been talking about, and also what your member benefits are. So if you're having trouble posting to groups.io or just accessing it, there's a video in there that I made a long time ago where I had less gray hair, and that tells you how to do that in more precision. So hunt that down. If you do have questions, though, Your primary points of contact are our board members at large, Wes Clem and John Pinto, reachable at bmail1 and bmail2 at cfas.org, or feel free to email me to president@cfas.org. And this is a part where I plead for help. The CFAS board needs you. Like I said, we are growing, and we do need some help. We're getting stretched pretty thin here. We're just a handful of volunteers doing what we can in our spare time. So if you are willing to step up, please do. I did send out an email to the group earlier today with more details, but just to recap, we are in need of a publicity chair, someone to kind of manage outreaching, external publicity, social media, stuff like that. So if that's your thing, do consider stepping up for that, or just serving on any committee you want. Even though we do have committee chairs in place for most things, we can always use some help. So whatever your expertise is, please sign up if you can. Education, events, programs, outreach, loners, treasurer, science website, membership, observing, or make up your own committee if you want. We'll take all the help we can get again. And we could really use a hand with a few specific things. First of all, on February 5th at 9 a.m., we're going to be moving the CFAS storage unit to a different place, and we're going to be saving quite a bit of money by doing that. So it's kind of an important thing, but it is a lot of stuff, so we could use a hand. If you're able to help out with that effort, please contact Chris Hunt at loners@cfas.org. We also have a big outreach event happening at Avalon Park on February 8th. They're expecting over 3,000 people at that one, so we need all the scopes we can get for that one, folks. If you can help, again, outreach@cfas.org. And there's also an outreach event happening at Gamble Rogers in Flagler Beach on February 15th. That's a shorter event. So, if you're new to outreach, that might be a good way to kind of get your feet wet. It's called the Cosmic Valentine Star Party. If you can help with that one, please contact Sharifa at vp@cfas.org. And a reminder, we are a tax-deductible organization. If you are so inclined, we are a 501c3. If you're looking for a last-minute tax-deductible donation, please consider us. There's a donate button at the top of our website. And if you work for Disney, we're now in the cyber grant system as well. So you can donate through them and get a matching grant, which is cool. Hey, I just saw a note from Christopher Hunt. Thanks to Bart, we have most items moved into the new storage. Thanks, Bart. Seriously, thanks, Bart. That's awesome. That's really awesome. Appreciate that. Moving on, upcoming astronomical events. Again, our next meeting's in just a couple of weeks, so not a whole lot happening between now and then. Of course, we're still keeping an eye on Tau Corona Borealis. Is it about to pop? Anytime now, I hope. We've been watching it. Well, we've been watching it all we can because it's been kind of cloudy here, huh? But keep an eye on it. It should be a fun nova when that finally happens. Any day now, they say. And on February 1st, the Moon and Venus will be within 2 degrees of each other, so that should be a fun little observation event, or maybe a photographic event if you have a wide enough field of view. And the winter Milky Way's out, so there's lots of great nebulae to photo and just look at if you can. The Orion Nebula's out, California, Flame, Heart, Soul, Jellyfish, and a lot more. We'll see a few of those in our Astrophotography Showcase in a little bit. And with that, let's move on to our next presentation. Bill Castro is going to talk to us about moon references and taking lunar observing to the next level. Bill, are you there?
Yeah, let me see if I can share my screen and get this up.
While you're doing that, Al B, I see your message there about having trouble sending emails to the group. Actually, Wes gave me a heads up about that, Al. So I did check. Your account does seem to be in order on groups.io. If you can find that introductory welcome to CFAS email, you might want to watch that video if you haven't already on how to do your first post. It's not exactly intuitive. If you have any trouble, though, feel free to message me directly at president@cfas.org, and I'll try to get you sorted. And Bill, take it away.
Yeah, I'm sharing my screen.
Nothing yet.
Is that better?
No. I do have a copy of your slides loaded up here if you just want me to go through them for you.
Yeah, why don't we do that? I think it must have changed since the last time I
Yeah, no worries.
zoomed in.
Yeah, so just say next slide when you want me to move forward or whatever. But
Okay.
Is that coming up?
Yeah, I got it now. All right. So this presentation is aimed at the many members we have who are newer to astronomy, and then with the club's emphasis on deep sky, it might be something for here for the seasoned observer as well. Go to the next slide, and that's the agenda. we'll see. The reference materials are listed in order from what I use the most. Additional references that I'll talk at the end are ones that I use every now and then. And this is a brief mention of the reference materials and why I like them. There are other materials that you might like better. Your mileage might be different. And hopefully this starts a discussion on who likes to use what and helping them look at the moon. Next slide. So why observe the moon? It's renewed interest with space exploration at the Lunar Reconnaissance Orbiter. New spacecraft are being built for manned and unmanned landings, possible base for launching into Mars, and then just talked about mining on the moon as well. It's visible in light polluted skies. It always looks different, even in the course of one night. Now you note on the left, there's a picture of the lunar X and the lunar V, and this is 3 shots over an 82-minute sequence. And you notice, well, I have the V and the X also in yellow, so you can know where those lunar features are. And those are visible a little bit before first quarter moon. And the craters there form the shape of the X and V under the right illumination. But what's interesting here is that the red circle of the crater there, if you look at the crater floor and keep going to the right, you see the shadows change over time. And that really illustrates how fast that changes, just in the course of one night. And the sketch on the right is what I made. If you're sketching, you got to sketch fast and not too close to the terminator, which is what I did there, or else it'll look different as you go. In this sketch, I only had time to sketch the main crater, a couple of other smaller craters around it. By the time I got to the wider area, the shadows changed, the view looked different, and I just cried uncle. I couldn't do it. And next slide. So this is the Atlas of the Moon by Tonin Rukel. I use this the most. I couldn't find a new one anywhere. The copy I got was from Astronomy magazine back probably 25 years ago, I'm guessing. I don't know. There are some available used at Amazon. Tons of other material on the moon references those maps in that book. The main part of the atlas consists of a detailed map on the near side of the moon, and it's subdivided into 76 sections. It shows the moon as it appears from Earth at 0 libration. And if you're new, that means it's tilted one way or the other. Sometimes you see a little more on one edge or the other. So it outlines the craters and other features that are practically the same as appear through a telescope, and that's not inverted like you would get if you had a diagonal, star diagonal on your scope. And the craters on the limb appear elongated from Earth as they appear, through the telescope. It's what you want. Now, this is different than an atlas that's composed of pictures from the Lunar Reconnaissance Orbiter. The craters are round from an overhead view of the orbiter. And then special maps of libration zones are found at the end. All right, next slide. Thank you. Here's an example of one of the sections. Each of the left-hand pages contain a description of the principal feature of the adjacent mapped area on the right. The moon's surface is drawn as it appears under morning illumination. So in other words, when sunlight is falling on it from the right. And this is my go-to book to identify anything I've seen, imaged, or sketched on the moon. And go to the next slide, please. Okay, next one I use a lot is the field map of the moon. This is from Sky and Telescope. It's still available. And I often have it on a card table with a bright red flashlight next to it. It's on a card table next to the telescope. And I'll use this at an outreach or at home by myself. I use a mirror image map because I have refractors and a Schmidt-Cassegrain telescope with the star diagonal to get the left-right swap. So that looks exactly like I would see through the telescope. There's also an erect image map available, and both are laminated and weather resistant. So it's big enough to see details at night. But it takes up quite a bit of space. It's 24 inches by 24 inches. And the next slide. So this book takes you to the next level of observing. Charles Wood, he has an Exploring the Moon column in Sky and Telescope magazine. The Modern Moon, A Personal View, is an authoritative guidebook that tells readers both what to look for and also tells you why to look. Details of craters, mare, other lunar features are explained as to how they are formed and the underlying and overlaying geology. It's aimed at amateurs with a small telescope looking at the moon. So from the inside jacket, it states, this book turns every reader with a backyard telescope into a field geologist equipped to unravel the moon's past and understand its present. And I can't say it enough that after reading this book, the moon will never look the same. The downside is that I haven't seen one. It was published by Sky and Telescope. I don't know if they're publishing books anymore. I don't know if they're new ones. I've found some available used at Amazon. Next slide. So some of my favorite books are no longer in print. I'm feeling really old all of a sudden. Yeah.
You and me both.
So, yeah. This is how I read that book. When a feature is discussed, kind of my pet peeve is it would be nice if the reference is a figure, it's a few pages before. But I found that having that lunar globe in front of me or the map helps a lot to place that feature and where to see it while reading. So there's a lot of detail discussed in the book, but it's not a graduate level presentation where you're trying to take a drink out of a fire hydrant. But you want to come up for air to take notes every now and then. Details on different types of crater formation, basin formation, mare, lava flows, mountain formations, stratigraphy, and some of the things discussed. Next slide. So here's an example of the stratigraphy. I hope I'm pronouncing that right. That's the order and relative position of strata and their relationship to the geological timescale that's discussed in the book. Now you got to read the book to get the details of these systems and formations. There's just too much information to cover all of that in this presentation, but excuse me. But generally, going from younger to older, you've got in that picture on the left, there are younger craters with central peaks labeled 1 and 2. Then you've got the mare itself, it's labeled 3. A crater with a flooded lava floor covering the central peak is labeled 4. The older mountains are labeled 6. And again, I can't say it enough that once you read this book, you'll never look at the moon again the same way. Next slide.
Yeah. Bryony confirms you did say that right and explained it right too. So
yay.
Well done.
Yeah, Google works great on how do I pronounce this. And then here we've got the moon globe. I use this every now and then. I have the 12-inch one. I got it through Astronomy magazine. I prefer the 12 inches. It shows details that you can see with the telescope. There's a 6-inch globe that's available, but it has less detail on it. And I got the 6-inch globe for Mars because that shows about what I can see through a telescope on Mars. But I like the 12-inch a little better. It looks good on a bookshelf. It does take a lot of the room on the bookshelf, but I think it's cool. Now the images are put together from the Lunar Reconnaissance Orbiter camera, which is overhead, unlike the view from Earth that's shown in the Ruckel book. Next slide. Okay, so additional references is the Lunar 100 card. I have it here. And if you're into a list of things to look at and check off on features of the moon, this is a good one. On the front, there's locations of these 100 features to look at and check off. On the back, it gives you the listing of them, and the feature name is another column for significance. It's latitude and longitude, the diameter, and it also references the Ruckel chart so you can get a better view of it. So this works out quite well. That book is Spiral Bound, the 21st Century Atlas of the Moon, again by Charles A. Wood and Maurice J.S. Collins. That has recent images of the Lunar Reconnaissance Orbiter in it, and it references that Lunar 100 card. But what's good about that atlas, it's kind of a Reader's Digest of Mr. Wood's more detailed book. And it also shows pictures on the edge, a little bit elongated as you would view them from Earth, not unlike the lunar globe. Excuse me. And last but not least, there's the Astronomical League. We have 3 lunar observing programs. There's a pamphlet you can order online that helps you go through those observing programs, and they have lists that they want you to observe and check off as well. All right, last but not least, the next slide. So if you have any questions, put them on the group's IO page. Maybe we can start a discussion with that and get people looking at the moon again. A lot of times, we're so interested in deep sky observing, we forget you can look at the moon. Start simple, do your homework. I like using observing logs, especially with different sun angles. Certain craters and features look a little different. And then last but not least, is there anything new still in print that other people like and want to recommend? Put that on the group's IO page. That's it.
Yeah, thank you, Bill. I mean, we take it for granted. There's a whole other world like right there, and you can see a lot on it. So definitely get out there. Um, there is like a 3-volume set that was popular in the club a few years ago. Was it Luna Cognita? I think it was. I don't know if you saw that one, Bill.
No, I didn't.
Yeah, I ordered it and Amazon screwed it up and only sent me 1 volume, but I hear it's good. So maybe I'll
Oh, geez.
Yeah, cool. Thanks so much, Bill. But yeah, we have some lunar photography to show as well tonight, and to kick off our astrophotography and sketching showcase here. And as always, if you're on board here, if you're live, I'm going to just turn over the mic to you so you can talk about your submission yourself. I'm going to kick it off with Eric Hoyne. Eric, are you here? You're not here, are you? I don't see you in the list. Eric, if you were here for our last in-person meeting at the planetarium, you might remember that our speaker presented on the Star of Bethlehem and how one candidate for that was Halley's Comet. And he joked that some members might remember the 1920 appearance, pointing at Eric Hoyne. Well, Eric submitted his photo from 1920 as a joke. He wasn't really there, folks. It's just a joke. But there's Halley's Comet from 1920. But back to the moon. Landon Worley got a submission. Little shot there from a Celestron tabletop telescope and an iPhone. Yeah, if you're online, Landon or MA, just pop in. I don't think I see you here, but feel free to unmute if you are. If not, yeah, we definitely encourage you to photograph the moon and observe it. It's a fun target. And also, I hear that they have a sea star now, and they'll be taking some really amazing photos of the moon going forward and other stuff too. So those sea stars are awesome at both lunar and solar photography, as well as deep sky. So thanks for the submission, Landon. Up next, John Pinto. I know you're here. John, you want to take yourself off mute and talk us through what we're seeing here with the Sea Star S30?
Yes. So I got one of the new sea stars. This is the smaller baby version, people are calling it, baby sea star. And what's nice about the sea star, this particular sea star, is it has a much wider field of view, and it also has a larger dynamic range. So you can get the full range of a lot of targets without things getting blown out that easily. Obviously, there are downsides too. What we've been discovering with the sea stars is in the corners, typically the top left corner, you're getting a little bit of elongated stars, but you really have to kind of blow these up, supersize, we call pixel peeping, in order to see that. But at the scale that Frank is showing it, it just looks gorgeous. This is M50. I'm also using a little feature that's in the sea stars now called mosaic mode. So you can basically even pick a field of view that's even larger than it does natively. And this is, oh, Frank, I see Bill's question. Yeah, I believe the S30 is 1.5 degrees by about 2.5 degrees natively. But it has the ability to do this mosaic mode, and you can basically double that size. So you can go, like 3 degrees by 4 degrees or something like that. It's an amazing field of views you can do with these things. Obviously, it takes more time because it's taking a whole lot of different pictures and stacking them all together to create your larger screen size. The other thing Mosaic does is it does cut down a little bit on the elongated star problem. And most of that's just because, this is a $350 telescope, right? So it doesn't have a field flattener in it, or any of the other high tech things you'd have in a full astro rig. But hey, for $350, you can get something like this fairly easily. Just a little bit about the target itself. M50 is a fairly young open cluster in our Milky Way. This is in the constellation of Monoceros, the unicorn. I don't know if you knew that there was a unicorn constellation, but there is. It's the next constellation that rises right after Orion. It's to the left of Orion. And let's see what else. It's young. It's only 150 million years old. We may not think that's young, but for clusters, that's fairly young. And it's about the same age as M35, which is the famous open cluster at the feet of Gemini. It's about 3,000 light years away. So that's about it. Thanks, Frank.
Yep. And I think you have a comparison shot with the S. Oh, this is at the non-mosaic version, right?
Correct. So I don't know, Frank, you can blow up that top left corner to show them what the elongated stars look like, but
my zoom foo is not that good, I'm afraid.
Yeah, that's fine. But if you were to look at this, this is just the native field of view, and you were to look at that top left corner in pixel peep, you'd see little egg-shaped stars, even though the center, I think
I did it.
Yeah, cool. Yeah, and you would probably even have to go even a little bit more to see if it would let you to get the egg-shaped stars. But the center is nice round stars. Nice round stars. And so just something to be aware of. If you don't really care about that, they make beautiful images. Thanks, Frank.
Cool. Thank you. John Starr, I see you're here. We got a few from you. And I think we mentioned the Dolphin Head Nebula earlier when we were looking at the Bryony's gorgeous picture of the Bubble Nebula. Wow. Want to talk us through this?
Sure, yeah. Yeah. So this one is a fun one to shoot. I haven't shot it in several years. And it's kind of low in the sky in Canis Major. I only get about 5 hours on it before, when it rises over the neighbor's trees and then ducks below sort of my house. So I shot this over 6 nights about a week and a half ago when we had that string of clear nights, which was sort of fantastic. This was shot. This is a bicolor image, so it's narrow band, hydrogen and oxygen, about 300 images, 5-minute images, and I love it. I love the colors of it. It was fun to process. The apparent size is a little bit larger than a full moon. The actual size is like 60 light years across. And that central ray star there, sort of in the middle, is what's sort of causing this with these particle winds. So really, really cool, neat shot. Probably could spend 3 times as long on it and still not sort of do it justice. But this one is a fun one to shoot.
Yeah, well done, especially with the limited exposure time there. Most people go all in on oxygen on this one I've seen, so that extra depth from the hydrogen really adds something to that image. I think it's gorgeous. So, thank you so much.
Thank you.
Cool. Jason, you're up next.
Hey everyone.
Hey.
So this is these next 3 images. These are my first night with the new Skywatcher wave mount. This is the Rosette Nebula. Spent about 6 hours on it. I think I did 3-minute exposures. And I'm learning PixInsight, so this probably isn't my best, but I kind of like it.
Yeah, it's gorgeous. Cool.
And then we got the Heart Nebula. Um, this is where I learned not to be afraid of stretching in PixInsight.
Mm.
It brought out a lot of the surrounding gas as well.
Yep, definitely see that. I think that part to the right's called the Fish Head Nebula too.
Yeah, the Fish Head.
Yeah. Yeah, it's good that you have a field of view that big to capture that. You know, most of us have scopes that we'd have to do a mosaic for that, which is no fun at all. But
yeah,
very cool. And the Soul.
And the Soul Nebula.
Next door. Very cool. Awesome stuff. Thanks so much, Jason. Beautiful work there. I got a few of my own too. So pay attention to this one, folks. This is the Soul Nebula as it really looks, you know, in natural colors. So all that glowy red hydrogen going on there, and you know, hints of lighter tones from oxygen and whatnot. But this is what it would look like if you had bionic vision, right? And you could actually see these faint colors in space. I visited that same object myself last month too during that run of clear nights, and this is what it looks like through narrowband filters, which is kind of a different take on it. So in this one, we're using what we call the Hubble palette, where red is mapped to ionized sulfur emissions, green to ionized hydrogen emissions, and blue to ionized oxygen emissions. Now, we do rebalance that to make it more visually appealing, to make sure that the red, green, and blue are kind of like the same levels. So there's a little bit of a artistic license going on there, but it does kind of bring out that different chemical composition of the object as well. And you can kind of get a little bit of a sense of the 3D structure of this thing too. You know, it's important to remember that these nebulas are not flat 2-dimensional objects that happen to be facing us. They're 3-dimensional clouds of gas that we're kind of looking into. And sometimes when you're looking straight in, that oxygen is kind of what pops out to you. But this was a fun project. This is actually a 3-panel mosaic because my field of view is smaller, which means it took me over 70 hours of exposure time to build that one up. But hey, I'm happy with the result. I also got a shot of what we call Thor's helmet. So not quite as far south as the Dolphin Head, but still a southern target. So we can gloat about that to our northern neighbors. Get a little bit of a better shot at that. Also, kind of a cousin of the Bubble Nebula and the Dolphin Head, same kind of deal, where we have a really hot star blowing out a bubble of gas around it. In this case, the gas surrounding that gas kind of made these interesting patterns. And, well, with a little bit of imagination, it looks like Thor's helmet. To me, it looks more like a running Death Star or something, but to each their own. I forget how many hours that was, about 20 hours, I think, on that one. Again, through narrowband filters. And my most recent image is the distant galaxy far, far away, NGC 2841, about 50 million light years away. But what I really find interesting about this object is how many background galaxies are visible in the background of this image as well. Like, a lot of those stars are not stars, they're other galaxies. And some of them are like doing weird things where they're irregular or interacting with other galaxies in the background. So I just love these kind of like deep photos where you can really grasp the magnitude of the universe we live in and how many other worlds, how many other stars are out there. Every one of those galaxies, hundreds of thousands, you know, maybe hundreds of billions of stars in each one, right? I mean, it blows the mind. So it gives you some much needed perspective when things on Earth are maybe not going your way. Jeffrey Merrick, are you here? I think you are. Uh-oh. Oh no. Your audio is really messed up. You sound like a chipmunk. I'm not. That's really interesting. Is it just me? All right, Jeff, you have some audio issues for sure. But anyway, I'll try to summarize what you're showing here. Is it just me? It's not, right?
I hear it too, Frank.
Okay, good. Yeah, so anyway, Jeffrey's specialty is irregular galaxies, and he's offered to give us a talk in a few months going into that. So this is ARP 147, and he's also shared a photo of this unlabeled view as well. I wish I had your notes on this handy, Jeff. Gosh, I'm sorry your audio's not working there, but we will have you back later in the year to give a more in-depth presentation. I know you're doing a big presentation about an hour long at a convention in a few months, so we hope to share in that with you toward the end of the year. And that is the end of the show. So thank you everyone for joining us. Again, I'll see you again in just a couple of weeks in mid-February. Our next guest will be Amy Oliver from the Whipple Observatory down in southern Arizona. After that, we got our in-person meeting in March, and in April, our special guest is Abby Loeb. So I'll catch you next time. Thanks for joining us tonight live. And if you do want to watch this, I will get the recording of it posted on YouTube sometime tomorrow. Meanwhile, keep looking up, folks, and thanks for being a part of CFAS.